Hi everyone, in this video we are going to learn about indirect measurement. And what indirect measurement is when you measure something indirectly, meaning like not actually putting the ruler on it because that particular object is too large to measure directly with like a ruler or tape measure. So basically indirect measurement uses the property of similar triangles. And the fact that similar triangles or anything that's similar is proportionate, so proportionality there. Indirect measurement uses the properties of similar triangles to find measurements that are difficult to measure directly, because maybe it's, you're measuring a big building that's over your head using what's called similar triangles. So a type of indirect measurement involves shadows. Yes, actual shadows. So let me show you what we mean by that. So we've got a flagpole, which is larger than you as a human, a flagpole that's casting a 32-foot shadow. And that's happening at the same time that Evan is casting a 9-foot shadow. And now Evan is 6 feet tall, so how tall is the flagpole? So here's how we would draw a picture of it. Here's Evan, and he's wearing a hat, okay? And Evan is casting a shadow, and Evan's shadow is 9 feet, all right? And then we have a flagpole, and here's the flag. Okay, I'm not an artist. And that flagpole is casting a shadow, and the shadow of that flagpole is 32 feet. Now, Evan is 6 feet tall, and we want to find how tall the flagpole is. So what we said was we were going to be using the properties of similar triangles. And here's how the similar triangles are created. And now we have two triangles. And I kind of made Evan a little bit large here. Clearly the flagpole, let's make our flagpole bigger. Here, let's make it much bigger. Okay, there we go. And then we gotta just fix our triangle. Okay. Oh, come on, triangle. There we go. So now this looks a little bit more reasonable. Here's Evan, and here's that flagpole. So we're going to be using these similar triangles, so we can say height is to shadow as height is to shadow, because since these triangles are happening at the same time, that's the kind of the key phrase here, these things are happening at the same time, then these triangles are similar. Remember, similar means that you're the same shape, but you're different sizes. One is smaller than the other. And similar figures are proportionate. So we can set up a proportion with their corresponding sides. So let's say height of Evan is to shadow of Evan, and height of flagpole, which we don't know, is to shadow of flagpole. Height is to shadow as height is to shadow, and again, this one was Evan, and this one was flagpole. And now we could do cross products and solve for x. So we've got, let me get my pen here, we've got 9x is equal to 192, using my calculator to multiply 6 by 32 quickly. Divide by 9 on both sides, divide by 9, divide by 9, to get that x is equal to 21.3 repeating, also known as 21 1/3 feet. So, 21 1/3 feet. There we go. So the flag pole is 21.3 repeating, also known as 21 1/3, because 0.3 repeating is the fraction 1/3, 21 1/3 feet tall. So if Evan is 6 feet tall with a 9-foot shadow, the flagpole is 21 1/3 feet tall with a 32-foot shadow. So now I'd like you to pause the video, and using number 1 as an example, I'd like you to try number 2, and I'd like you to try number 4 and number 5. And once you set up those relationships and draw your pictures and get your answers, unpause the video so that you can check your answers. Try that now. All right, so you have done number 2, the stop sign casting a shadow that is 4 feet long at the same time that a tree casts a shadow. And we are finding how tall the tree is. That tree is 63 feet tall. And we should have set up the proportion 7 is to 4 as x is to 36. For number 4, we were finding a 45-foot water slide casting a 30-foot shadow, and we were finding the length of a shadow of the 4-foot tall child who's standing nearby. 45 is to 30, as 4 is to x, for a final answer of 2.6 repeating feet, or 2 feet and 2 2/3 of a foot. Sorry, 2 2/3, because 0.6 repeating is the fraction 2/3. So 2 2/3 foot for the 4 foot. 2 2/3 feet for the shadow of the not 4-year-old, but 4 foot tall child. And Amara is 5 feet 6 inches tall. So she is 5.5, because 6 inches is half a foot, 5.5 feet tall with a 2 foot long shadow. At the same time, a roller coaster casts a 120 foot shadow. And how tall is that roller coaster? It is 330 feet. So let's take a look at example 9. Surveyors also use similar triangles to find distances that do not involve shadows. So given these diagrams, let's find each missing measure. Here, the triangles below are similar, and let's go ahead and find x, which is the distance across the river. So we have a river, which looks like it's right here, and x is the distance across the river, okay? And we know that this measurement is 15, and we know that this measurement, let me do that in a different color, this measurement right here is 24, and we know that this is 82.5. So let's set up, we do have 2 triangles here. It looks like we got triangle 1 and triangle 2. So let's set up a proportion. X is to 82.5. So x corresponds with 82.5. So x is to 82.5 as 24. So if I started with triangle 1, I should end with, or start with triangle 1 again. So as 24 is to 15, as 24 is to 15. Now we also could have done x is to 24, x is to 24, as 82.5 is to 15. So either of these 2 setups are accurate. X is to this as 24 is to that, or you could just go x is to 24 as 82.5 is to 15. As long as you're setting up things that correspond, all right, that correspond in a relationship when you set up that proportion. Now when we do cross products and solve for x, our cross products, let's do this one here. Okay, our cross products are going to be 15x is equal to, let's multiply with our calculator, 1971.6 divided by 15 on both sides to get that x is equal to 131.44 feet. And that's the distance across the river. So using that as a sample, try number 10 to find the distance from Avon to Franklin. Pause the video now and try it. Okay, so there's a couple ways you could have set up the proportion for number 10, but I set it up using 128 is to 150 as 80 is to x. So 128 is to 150 as 80 is to x, because this is what we're looking for. 128 matches with this slanted 150 on this triangle, where 80 matches with this slanted x on the smaller triangle. Those are proportionate, as these are similar triangles, said so by the question. And cross products solve for x to get 93.75 miles. Take note of any questions you had while watching the video and taking notes, and go ahead and let me know what questions you have, and we will practice this some more in class. Thanks for watching.